Hello, welcome back to solving systems of equations. We're going to learn how to use the techniques of graphing to solve systems of equations. Now, in the last section we talked about that there are three main classes of systems of equations, right? The first one is the most common. That's called a consistent system. A consistent system is just when you have line number one and line number two, they cross somewhere, and then they have a common intersection point. That's the solution. So we could say it's consistent. Right? But we also could have the possibility of having two parallel lines that never cross anywhere. And so there's no solution for that. That's called an inconsistent system, right? Because there's no solution. And then we have a third case where it looks like there's two equations, but they actually turn out to be the same equation with basically both lines sitting right on top of each other. Like literally they end up being the exact same lines. And we call that a dependent system. And we're going to get into solving all of these kinds of equations, but here we're going to learn how to use the technique of graphing. Now, the one thing I'll tell you is a lot of students will ask right in the beginning, why do we have so many different ways of solving systems of equations? Well, the first answer is systems of equations are really, really important. And I'll get on into that in just a minute after we finish our first example, why they're so important, or give you some motivation. But the other real reason is when you're reading something off of a graph to find the answer, it's actually hard to be very precise. In these examples, the lines are going to cross at very specific points, so it's easy to read them. But if the lines cross at negative 3.125, comma, negative 2.796, it's hard to read that off a graph. So these, just keep in mind, graphing is a very important way to learn how to solve systems, but it's not excellent and amazingly precise if you have to read decimal points. So that's why we have other methods. So let's jump right into it and solve our first system of equation by graphing. The system is the following. Y is equal to 4x, and the other equation in the system is x plus y is equal to 10. Now right away you can see that this one is given in slope-intercept form, mx plus b, of course b is 0 here, and this one's given in standard form. It doesn't matter how I give you the equations or how your test gives you your equations. You know it's a linear equation because you know that x and y are the only two variables and they only have single power exponents. There's no squares or cubes or anything like that. So that's all you need to know. If it's just x and y with no exponents other than 1, it's a linear equation. It forms a line. So what we're going to do is work down here. Now this, this line is very easy because it's already in slope-intercept form. So the slope here is 4 and the y-intercept is 0. Very simple. On the other one, we have to do a little work first. Let's solve for y. We'll subtract x, so we subtract it from both sides. Now that we have this here, we know that the slope is negative 1 because it's what's in front of the x, and the y-intercept is 10. So what we're going to do is graph both of these and see if we can figure out what the intersection point is just from the graph. So the first one, the y-intercept is 0, which means it goes right through the origin. Y is equal to 0 right there. And the slope is 4, which don't forget, when you have a whole number, it's really 4 over 1. That means you rise 4 and you run 1 to the right. So up 1, 2, 3, 4 over 1. So this is the second line right there. All right. And so what we're going to do, just double checking myself here before we go on, is do our best to line this up. It's really important when you do your graphing, if you're really trying to find a solution by graphing, to really take a second and line everything up, get a good straight edge and all of that. Otherwise, you're just wasting your time because you're really depending on having straight lines, and even this line isn't perfect, but it's close enough for what we're going to do today. Now, the next line is y-intercept of 10, so we can go right up here.